Welcome back, my friends. Time for another video. This time, IM3 Part 2B. That's the second page of Part 2. Numbers 37, hopefully through 45. And we're going to talk about a couple things. So, in the previous video, we talked about converting radians to degrees. This time, it's degrees to radians. So, it's very simple. Let me actually zoom in here for you guys. No need to zoom out. So the way you convert from degrees to radians is pi over 180 degrees. And I always just remember, if you're confused on which one goes on top and which one goes on the bottom, if you already have an angle with a degree and you want this to cancel, it has to be on the bottom. It has to be on the denominator. And that's what reminds me that degrees go on the denominator. So the pi is going to stay. 285 and 180, what do they have in common? How can I simplify that fraction? So what I'm saying is this is 285 over 180 pi, but I can simplify that fraction. And so I'll just take out a common factor. So I can see they're both divisible by 5 because they both end in a 5 or 0. So I'm going to divide top and bottom by 5. So that's going to give me 57. And on the bottom, it's going to give me 36. Now I can also see that they're both divisible by 3 because their digits add up to numbers divisible by 3. 5 plus 7 is 12, which is divisible by 3. And 3 plus 6 is 9, which is divisible by 3. So I'm going to divide top and bottom by 3. And I'm going to get 19 over 12. And 19 is a prime number, so I know it can't be simplified anymore. So those are relatively prime, and that is our answer. And I'll trust you to do the same thing with that one over there. And I'm going to move on. So for number 39, it says find the exact value of each trigonometric function. And I will do more of these because these are a little more complicated. So sine of negative 150. Well, you could just say, well, I have a unit circle. You know, I'm just going to go on my unit circle, and I'm just going to look it up and see what it is. And that's certainly, I don't have a problem with that. Where is sine of 150? Well, if this right here is the x-axis, right? So if you go clockwise instead of counterclockwise, and you go 90 degrees, then 60 more will get you to that angle. Maybe I should use a different color. Okay, so that will get you to that angle, and this will be negative 150. But, you know, it's the same thing as if I go over here this way, in this direction. But instead of 150, I go 210 degrees. Why 210? Because that would be, those two, their absolute values would add up to 360. So, in other words, what I'm trying to say is that this is the same thing as asking for the sine of 210 degrees. I suppose either way, you don't really care if you have the unit circle handy. But if you don't have the unit circle handy, what you can do at this point is to realize that, hey, there's a triangle here. If you just look at that part, you know, and I have this right here, and there's a triangle here with that green arrow. Well, 180 is that top half of, you know, the coordinate system. So this right here is just 30 degrees, right? And this hypotenuse here is 1 because it's a unit circle. And so from that, I can tell that this height here, for example, in a 30, 60, 90, this has to be half of the hypotenuse. And this side over here has to be, maybe that wasn't the right color, but it's root 3 over 2. And they don't care about the x value. They don't care about it being left root 3 over 2. They care about how far down this goes. So what I'm trying to say is that this coordinate here is negative root 3 over 2, comma, negative a half. And the sine is simply this value right here. It's just the y value. So the answer is negative a half. Lovely. Number 40. pause this one and see if you can do it yourself. And then wait for the explanation. Now we're back. So this one here, again, negative 315, this is just tangent of 45 degrees. And I really prefer to think of it in the positive terms. But, you know, yeah, okay. And tangent of 45, that's super easy because it's just 1. And the reason why it's 1 is because 45 degrees, you know, you have some coordinate here. And you know that this right here is 1. Well, what are the other two sides of this triangle? Well, it's isosceles, right? And literally isosceles, right? It's isosceles, right? Right? Well, that means that this is root 2 over 2, and the other one's root 2 over 2. So because they are the same, and remember, tangent is just sine over cosine or opposite over adjacent. Dividing two things that are the same by each other just makes it 1. And again, you could have this on your unit circle already written out if you have a unit circle ready to go. There's nothing wrong with writing out the tangent values. I think that would be very smart if you wrote out the tangent values onto your unit circle. So it takes a little bit more time, but you know, it could save you some time on the final. You know, less thinking for you. You just look it up, really quick and easy. That's something I would do in advance if I were you. Number 41. Cosine of pi over 3. Well, again, unit circle, my friend. So this is simply 60 degrees. So it's like this right here. And if this is 1, and that's 60 degrees, then this is the shortest side. So this is a half. And then this would be root 3 over 2 because of Pythagorean theorem. And the reason why I know this is a half so quickly is just because I know, one thing I would say is that you should have your 30, 60, 90 triangles memorized, especially with a hypotenuse of 1. That's like all the stuff that I remember that I memorized for the unit circle. If you just know your 30, 60, 90 triangle and your 45, 45, 90, you have the whole unit circle memorized. And that's really all I do. I don't really have it like memorized in the sense that, you know, just like, boom, I know what it is. I'm constructing these triangles in my mind, and that's how I know the answer. So cosine is simply a half because it's the x value. Number 42. Again, try to work this out yourself. Now, just as before with this negative value, this one also has a negative value. And I was already thinking about adding 2 pi already, just because not only is this negative, but it's beyond 1 revolution, right? If, for example, what I'm trying to say is, like, if you had 6 pi over 3, that would be the same thing as 2 pi, which is 1 whole revolution. And so anything, you can add and subtract 2 pi all you want. It's not going to change the sign. It's not going to change the value of this. So what I'm saying is, if we just take this right here, this negative 8 pi over 3, and add 6 pi over 3, then we would get negative 2 pi over 3. And that's a lot more manageable. And if you want, you could also add 6 pi over 3 to that. And this, if you prefer the positive version, then that would just be 4 pi over 3. Maybe some of this terminology is not exactly right. I don't know if you care, but that's the sign of this. And that equals the sign of this. Okay, I'm just trying to be correct here. So all that to say that number 42 is actually just asking what's the sign of 4 pi over 3. And that is a value that you should have on your unit circle. So again, if you're looking it up, you don't have to do any more thinking at this point. You just look to see where you have 4 pi over 3, and you just see what the y value is, and then you're done and you're happy. I don't have that luxury here, so I'll tell you how I do it in my mind. This right here is 3 pi over 3, and 1 more pi over 3 gets you right here to be 60 degrees. So that means that this angle there, this in here is 60. And that means for me that this angle down here is 30, which means that this is a half, and that this is root 3 over 2. But then just remember which quadrant we are in, and the y value here is negative root 3 over 2, because it goes down. And this is my answer. If that confuses you, just write down the unit circle and all the numbers. All right, number 43. Now, I did have some of these things here labeled already, and I hope that makes it easier for you, because they ask, identify all parts of the sinusoidal, sorry, it says identify, not my typo, but oh well. Identify all parts of the sinusoidal equation A, B, H, and K, and then find the period. So here we go. So I have some of these things written out. And as you can see, A is simply the coefficient in front. And B, so I'm just saying A is 1. There's nothing written there, but I put it as 1. Because, you know, that's the value there. And then B is, so A is 1, B is 6. The stuff inside the parentheses, it kind of got covered up here, but that's the parentheses there. Let me try to redo that here. This is your H. H just shifts it left and right. Okay, so it just shifts that left and right. And then the red one shifts it up and down. So the question is, what is the period? And the answer is that it's 2 pi over b. So in this case, we get 2 pi over 6. And so the period here is only pi over 3, which means it does a full revolution. Normally it takes 2 pi to do a whole revolution. In this sinusoidal, it only takes pi over 3, which tells you that it goes faster. So more waves in less area left and right, less horizontal distance. Okay, I hope that explains that. Do I have to do 44? I hope that would imply it. So A is 4 and B is 7. And that's all there really is. And just put 2 pi over 7. And that's number 44. Last one here. This is the last question of the page. Find the median and mean for each data set. All right, let's find the median. So how many terms are there? How many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there's 21 terms. Half of 21 is 10 and a half. So the 11th number is the median. And as we know, so this was 10. So the 11th is right here. So that means that the median is 49. But what's the mean? Well, we have, we just have to add up all these values. And that can be a little cumbersome. You know, we have 57. So one thing I would do to kind of shorten this just a little bit is to say, look, this is 5 times 53. And this is 3 times 54. I don't know if it's really saving much time, but you know, maybe a little bit. Okay, so we add that up, and I'm just finishing up right here. This is a little bit cumbersome. There are a lot of numbers. But the point is that once you're done adding all the numbers, you simply divide by the numbers that there are, the number of numbers. And in this case, we said there were 21 numbers. And so we just did that by half and then rounded up. And if it's an odd number of numbers, that's really easy to do. If it's an even number of numbers, you divide by half. And between that number and the next number, that's where your median is. But for the mean, we just add them all up. So we got 1,006. Divide that by 21. And it's 47.9-ish. So 47.9. Thank you for your patience. Hope that was helpful to you. In fact, let me write that real quick. The sum was 1,006. That was the sum, and the number of numbers was 21. And so that equals 47.9. And that's because the mean is simply the sum divided by the number of numbers. We'll call that n, or you can call that, you can just put the numbers, like this. And that equals the average or the mean. And that's all you had to do. There is, of course, another part, but tomorrow we'll do part 3. Thank you for your patience. I hope that was helpful to you. Please like, share, and subscribe. Buy my merch.